Alright, so in this video we are going to be going over a C++ concept that we find is often really useful for students when starting this class, which is how parameters are passed in C++. So we're going to start by having you kind of think a little bit about this code. So here we have a vector. It is a vector of doubles. It's called myvec, and here we're putting some stuff in it. So here we put in 3.14, put in some other doubles into the vector. Then we're going to call a function called add one to each. So this function is just intended to take each element inside the vector and add the value of 1 to each element. And then here at the end you can see we are just going to be printing out the vector so we can see what it has contained in it after calling add one to each. What does add one to each look like? So add one to each has a vector coming in. It's called capital V, and then here you can see that we are looping through all of the elements in V and adding one to each element. So the question is that it runs, but the outputted values haven't changed. And so what's going on? Take a second to pause the video and think a little bit about what could be causing this problem. So basically, this is a function that's supposed to add one to each. We run it, and it has all the values are staying the same. They are unchanged. So having a second to think about it, hopefully you came to the conclusion that the problem here is that you are not passing by reference inside of the add one to each function. So the idea here is that when you write a function as it is written here, by default C++ is going to make a copy of what you pass in. So this here is going to be copied, and the copy is going to be changed in the function, but the original is going to remain unchanged. And so that's what we're going to look at is an example and map out the memory on what that looks like in more detail. So by default in C++, all parameters are passed by value. If you would like to pass a parameter by reference, you use the ampersand symbol inside of the function input sequence. So the parameter then has this ampersand between the declaration and the variable name. So let's look at an example that shows you what this actually does. Okay, so here I have a little memory map, and I'm going to go through this function here, which is really simple purposely so you can really see how it works. So when you look at this function, we're inside main, and the first thing that happens is there's a variable declared and it's filled with the value of 0. So somewhere in the stack there's going to be some memory sectioned out that fits an integer, and it's going to be initialized to the value of 0. So I'm going to kind of draw this out with arrows, but do keep in mind that I'm not making these aren't pointers, but I'm just trying to direct you to where in the memory that variable is stored. So we start off with 0, and then what happens? So then function f is called. So we're going to go up to here, and inside of function f you can see that the parameter x is the integer that's passed in, so that means the value 0 is passed in for the parameter x. But what's happening is when x receives that value of 0, it doesn't have direct access to that value. Instead it makes a copy. So x has the value of 0, but it's pointing to a different 0 in memory than the original 0 that is pointed to by I. Not pointed to by I literally, but figuratively. And so here we're in function f, and what happens in function f? Not too much. All that happens in function f is that it calls function g. So again, x is passed in as the parameter y. So x is 0, 0 is passed in as the parameter y, and so y receives the parameter, or y receives the value of 0, but it does not have direct access to x's value, so instead it makes a copy. So now y is pointing to another copy of 0 in memory. So then what happens, you can see that inside of the function, the parameter y changes and it's incremented by 1. And as you then back out of the function, you can see that nothing else is happening, right? You're just backing out of functions at this point. You back out of g, you back out of f, and then you get into main. When you get back to main, you only have I, and I still points to 0. So all of those function passes make these copies, and these copies are all their own copy in this case. And so if you change one of the copies, the others don't change. And then what you'll learn about more when you take like 261, 361 is more about like how the stack is actually going to be erasing those copies as you move out of those functions. But for now, all you really need to know is that I didn't change, right? So the alternative is putting the ampersand in the function line here. So what happens here? So now, again, we're inside of main. Main has variable I, so somewhere in the stack, well not somewhere, a very specific place in the stack, you're going to find memory for an integer and you're going to initialize it with 0. So this is going to be for that piece of memory. Then when you go and you call f in this case, because you're passing by reference here, C++ behind the scenes is doing a bunch of stuff, but basically it's going to make a pointer and it's going to refer x now to the same location that I is. And so it's actually pointing to the exact same spot. What happens in f? F just calls g, so you go into g, and then when you get into g, again, this parameter is passed by reference as well, so it's not going to make a copy. That parameter is also going to point to the same thing that x pointed to, figuratively, and so that's also going to be 0. Then what happens? It's incremented, so here this is going to change to 1, and because all of these things point to that same memory, all of those variables are going to get updated to 1. So as you back out, the main function is going to still have I in it, right, as you back out of all those functions, and that I is going to have 1 instead of 0. So that's how pass by reference versus pass by value works. So it allows you C++ allows you to make this choice, but by default it passes by value. But the other thing is that you can also do other things by reference. So most of you have probably seen pass by reference in functions, but you also can return by reference. And this is typically like blowing people's mind a little bit in data structures. So it gives you a reference to the item being returned rather than a copy, just like in parameter passing in functions. So we're going to look at an example of this, but this is going to be used all the time when we implement a lot of our abstractions in this class, so pay close attention here. So have you ever wondered why when you declare a vector, push some stuff into it, print it out, got a vector, 1, 2, 3. But then you use this abstraction, this abstracted member function, which is the square bracket operator, and you access index 2 and you replace it with the value of 30, that it actually replaces that value. How does it do that, right? So how are you able to actually, change a value with the square bracket operator? Well, it works because of the ability to return a reference. And so this is something that you can actually go look at in project 1. So we give you an abstraction that we wrote called rvector, and it's like our own version of a vector class that you're going to use for your project. And you can go in and find this member function, which is the member function that describes the functionality of using the square bracket operator. And what do you see here? You see right here that the return of that function is a reference. And that allows you to get direct access to the vector. So if we have 1, 2, 3, and you want access to this element here, this return by reference allows you access to that memory location rather than a copy of it. And so what it does then is it allows you to replace this value with 30 with this operation right here. If you've never seen the T before, stay tuned for the next lecture, which I'll explain what that T is, but for now just imagine it's any type. But the reason this works is because we're able to return by reference. We're going to do a lot more with this. You're going to see it a lot more. You're going to practice with it. It's an easy thing to see work because you can take it away or add it back in to see if it's working. So yeah, and just to give you a very quick demo of pass-by-reference functions, let's go into Visual Studio and look at the example from the first slide. Here we have that add one to each, and then here's that code. So if we run this as is, you'll see that the before and after is unchanged. That's because if you look at the add to one, there is no pass-by-reference, but if you add it and you try again, you can see that now we have each element is one larger. And I encourage you to do the same thing with the return by reference that you'll see here in the R vector class that you have for the project, and you can see it for yourself as well. All right, so that's it. Thanks so much.